All right, Delaney, you are going to see Uncle Todd here in full teacher mode. So this is the problem you screen captured me, and I'll send you some resources for the ideas or the concepts. Um, I just sort of left the problem at the end. What do they want us to do? Is they want us to find the average force on the ball in kilonewtons. So before we put crunch numbers at the end, we got to realize we need to be in the right units. That's a metric unit. It's not in pounds. It's in newtons. So we got to make sure all the units that go into the math are going to work with that. So the idea of the problem is here's my jacked up golf club, here's my ball, right? What's going to happen is think about the idea first. Initially, the ball is stationary. Another way to say that is it has no momentum. Its velocity is zero. And then afterwards, so I might say that P, and that could be an issue too. Every teacher sometimes uses different variables, but traditionally in physics, lowercase p is momentum. So its initial momentum is zero. It's sitting still. And then we're going to hit it with the club, and we're going to give it some large final momentum. And momentum is a vector, so we draw it that way. So we're going to get a change of momentum of the ball. So momentum, right? So you're dealing with equations. P would be mass times velocity. That's how you describe momentum. The units for momentum, masses should always be in kilograms, and velocity should be in meters per second. So that's going to be an issue because I think in that problem, if I read it right, they gave you the velocity in feet per second. So you have to convert. So a change in momentum, change is delta. P could be written this way. It might be m times a change in velocity. And I might even expand that out then and say that's equivalent to mass times Vf minus Vi. So we'll think about it with this one. Vi is the initial velocity. The ball's just sitting there, so it's got no momentum to begin with. It's got no velocity, so that's a zero term. So this simplifies for this problem to just mass times the final velocity. How do you change something's momentum? Well, you have to push on it with a force. You could push with a high force or a low force. And you also have to exert that force over some time. Are you going to push on it for a long period of time, or are you going to push on it for a short period of time? So the combination of force and time is called an impulse. And that's why I would classify this as an impulse momentum problem. An impulse is what changes an object's momentum. So an impulse is quantified by the average force. In reality, it changes. It goes from low to high peak force and then back to low force. And the duration of time, which is delta t. So that's the problem set up. That's the mathematics of it, right? The impulse is going to cause a change in momentum to the ball, and you want to be able to calculate, given the information, what's that average force that causes that change of momentum. So the algebra at the end would look like this. That would be the solution then to that problem. So a couple things then that you got to notice is where there's some unit issues. The mass should always be in kilograms if you're going to deal with the standard metric units or SI units, and they give it to you in grams. So I'm going off memory. Check this. I think they said it's 55 grams. So in kilograms, that would be 0.055 kg. That's 2 sig figs in there. I don't know whether your professor thinks sig figs are important or not. The velocity will need to be converted, and the time does not need to be converted. The time duration, I think, was and again, check this, 0.0026 seconds. So it's a very short duration of time. So you do need to convert your velocity from feet per second to meters per second. And the conversion I would use would be this. There's 3.3 meters in 1 foot, and the velocity we're given was 120 feet in 1 second. So foot cancels foot, and that's going to be whatever you calculate. 3.3 times 120, it's close to 400, I think. So if sig figs are important, I don't know, you should round your answer to 2 sig figs, because that's 2 sig figs, that's 2 sig figs, and that's 2 sig figs, or that's a conversion factor, so it could be as many, but that's 2 sig figs. So your answer should be in 2 sig figs. So again, the physics or the ideas sort of come first, and this is sort of the details then what it sounds like you're struggling with is what is the mathematics that he's talking about? What's it describing? So I'm going to send you this video, and I'm also going to send you then some links to some videos that I made in years past for students, and maybe they'll help you, maybe they won't. If they don't help you, you feel free to text me or email me, and I'll try to set some other problems up for you. Okay, good luck.